D, E, and F are midpoints of the sides. If midpoint is mentioned, something is getting cut in half. Let's put some tick marks on here. When you have this type of diagram, each of these segments that connects the midpoints is called a mid-segment. So DF is considered a mid-segment. EF would also be considered a mid-segment. Typically, well, there's no typical problem. Sometimes you'll see all of the mid-segments shown in the triangle. Sometimes you'll just see one. That's just an example of one of the mid-segments. So if you see midpoint mentioned, you've got a mid-segment. If you see the term mid-segment involved, that means that each of these points, D, E, and F, would be midpoints. Be careful. You're going to be jumping between dealing with angles on this next test and dealing with sides. Always make sure that you know what you're dealing with. What are these things? Sides or angles? Sides. DE is right in the middle there. GJ is one of the sides.
Good morning, Bruins. Please excuse this interruption. Just please, teachers, please reiterate to the students that today's schedule is 1426. Thank you and have a great day.
If you've done the reading, you've come across the definition of mid-segment, which involves midpoints, but it also involves a relationship between this side. Anybody remember what the relationship was? There were two parts to mid-segment.
The big segment, the mid-segment was half of the length.
All right, half of the length, half of triangle side. So DE is going to be half of GJ. What else? Yep.
They're parallel one to each other.
Parallel. Let's put a little parallel symbol here and here. That's only if you have a mid-segment. And you're going to see little fractions like this pop up occasionally in the rules. You copied down some theorems the other day. You probably should have seen 1/2 show up and maybe 2/3. Was 2/3 one of the fractions you saw? That's going to be the extent of the calculation work that's involved. So if DE is half of this, I could write it exactly that way. DE is half of that side. Can you solve that equation? I'm going to leave that for you. Once you get X, make sure that you actually figure out the actual question. Jump to number 2, DF. Well, DF is another mid-segment, but now we're relating it to this side over here, HJ. It's still a mid-segment. It's still connecting midpoints, so this rule still applies. It's half of the triangle side. DF, which is 3y minus 5, is equal to half of HJ, which we're calling 4y plus 2. I'll leave you to solve that equation for homework. GH, which one is GH? GH is this side right here. And EF is another mid-segment. That mid-segment is half of GH. I'm going to write it this way. GH, which is the long side, is 7z minus 1. How many of the EFs would it take to make this? So I'm going to write it this way. You can choose whatever way you want to do this. You can either say that the small side doubled equals the big side, or you can say that the big side cut in half is equal to the small side. Whatever you choose to do. You're still going to get the same answer for your variable. Just make sure that you actually answer the question after you find your variable. You tell me, are these difficult? Is the calculation work hard? No. But you got to know your little rules. When you see algebraic expressions, things either add up to a total or they're equal. I've got something that's being cut in half, and I've got something that is at a right angle. Someplace down here, write down that I've got a perpendicular bisector. One of the rules in chapter 5 says that if you've got a perpendicular bisector, you're cutting that original triangle perfectly in half, which means that not only are these two sides equal, but these two sides are equal. You've got an isosceles triangle. The two little triangles are exactly the same. That would be my equation. Be careful. Know what the problem's asking for. You got to go back and figure out the length of BC in each of these. Well, number 5 to me looks exactly like number 4, only it's turned on its side. So if I'm seeing the perpendicular bisector, I know that these two sides are equal. I'm setting up that equation. You're going to see a lot of repetition on your next test. And it looks like number 6 is just reversed upside down. These two are equal to each other. A lot of this next unit, the unit that you're in, is testing whether or not you know your algebra skills. Those aren't too tough. I'll leave that for you to work on for homework. Here's where you got to do a little more thinking. Perpendicular bisectors. They are shown as dashed. So this is a perpendicular bisector. This is a perpendicular bisector. This is a perpendicular bisector. Did we do a matching worksheet the other day with some vocabulary? What did we call the point of concurrency, which in this case is point G? Anybody remember what that was called? Elizabeth thought she knew. She's not so sure. It's something like that. There's 4 choices, which, there you go. It's the circumcenter. Let's draw a little arrow to here. How did you remember that that was the name for that point? Okay. I remember it by the first syllable in each word. Per and cir. They sound the same to me. That's all. What does that mean? Center means that it's the center of a circle. It's not asking about this, but that would be the center. That's not a good circle. A giant circle that goes through each of the points of the triangle. It circumscribes the triangle. Well, why is that important? That's important because what do we know about the radii of a circle? It's half the diameter, but what do I know about all of the radii? They're the same. Isn't this line right here a radii? Isn't this a radius? Isn't this a radius? So I know that that is equal to that, which is equal to that. So when they're telling you that you've got all these perpendicular bisectors within the triangle, they're really telling you, take a look at the distances from that point to each of the vertices. Those are all going to be equal. Radii are equal. And we were told that this was a perpendicular bisector. So I can put in right angles here, and here, and here. And it said that it was a perpendicular bisector, which means that this side is equal to this, that little piece. This little piece is equal to this little piece, and 1, 2, 3, 4, 1, 2, 3, 4. So you know all of those sides are getting broken up into equal pieces. With all of that information and this information over here, you should be able to answer each of these questions. Let's take a look. What is AG? AG is one of these centerpieces, one of these radii. So if I know one of the other radii, then I know AG. Do I know any of the other radii? GC. GC is right here. That's 2.47. All of the radii are 2.47. So I could write over here GC equals 2.47. AG equals 2.47. Is there another radius? G to B, I'll write that in also. It wasn't asked for, but that's what I should be thinking when I'm looking at this diagram. AJ. AJ is from here to here. Let's see. CA, where's CA? CA is 3.38. Is that going to help me? What do I need to do? Cut it in half. What's 3.38 cut in half? 1.69? So I know that that's 1.69. I know JC. I don't see JC over here, but I know that that's also 1.69. And the reason I know all of this information is just because of the words. Perpendicular. You know what that means. Something got bisected. Something got cut in half. That's the sides. We know that all perpendicular bisectors meet at something called a circumcenter. A circumcenter is the center of a circle, which means we've got radii which are the same. Separately, all these little pieces of information are not difficult, but you got to put them all together in one drawing. AJ was 1.6. And we could write JC was also 1.6. AB. AB is this long side over here. So it might be helpful to know one of the pieces of that long side. Do I know any of the pieces of this? AH. So if AH is 2.42, what's going to be the entire length of that side? 4.84? Some people feel more comfortable by actually redrawing this picture and making it bigger so that they can put all the information in. If that's what you need to do, that's what you do. Whatever makes you feel comfortable with these problems. IB is this portion right here. I see CI right here. CI goes from here to here. That's 2.10. I see slash marks here and here. Number 10 must be also 2.10. Does that make sense? IB, yep. And we'll end today with number 11, something new. underline the word indirectly. For an indirect proof, I want to make a temporary assumption that is opposite. If it's phrased in an if-then sentence or statement like this, this is the part I want to make opposite. I want the conclusion to be directly opposite that. So, my temporary assumption would be x is divisible by 3. Let's see. Let me give you an example. Let's say I want to prove that Connor is a real human being and not a robot. I want to prove that he's a human being. So I assume the opposite. I'm going to assume that he's a robot. So Connor's a robot, and then I watch him for a while. Well, Connor sneezes. Do robots sneeze yet? No. When you see a contradiction to something that you already know, that means that your original assumption was incorrect. My original assumption was Connor's a robot. But I saw him sneeze. That's a contradiction to something that we know. Therefore, he must not be a robot. He must be a real human being. With this type of problem, let's see, x is divisible by 3. If x is an even number, let's look at a specific number. Let's look at the number 10. If x is an even number, then x is not divisible by 3. Well, let's assume that it is divisible by 3. So let's look at 10. Ten divisible by 3. But I'm getting a remainder. Do you get a remainder when something is divisible? So my original assumption must be false, which means that what's opposite to that must be true. It must not be divisible by 3. The next time I see you, we'll be doing some examples that don't involve numbers. It's a little bit more difficult when we're dealing with algebra. When we get to geometric indirect proof, you'll see it a little more clearly. But the idea is, whatever it is that you're trying to prove, you look to its opposite. This problem just wanted you to tell what the first step was. And that will be part of your test. You'll have a part 2 that won't be multiple choice, that will be on all proofs. And you might just have to recreate the first step in an indirect proof. And the first step is taking that conclusion and assuming the opposite, or assuming that x can be divisible by 3. For homework, just finish up the rest of those equations that I set up earlier. And next time I see you, we will continue with the other side of this worksheet. You can take a look at it. You can work through it if you want. I'm going to be doing it in class.